Pretty eyes, pretty thighs, shawty, she a dime. Demon girl, evil eyes, she be telling lies. Slim waist,
All right, so today it is my pleasure to interview Dr. Jennifer. So, Dr. Elisseeff, thank you for being part of this episode. In light of a really illustrious career, can we start with you taking us back and telling us about your background?
Sure. How far back do you want me to go?
I don't know, maybe just a general background.
Yeah, so I actually started off as a chemistry major because I couldn't decide between biology and physics. I wanted to do both, with a little bit of engineering mixed in there. And then I went to graduate school and combined my interest in medicine. So did most of the first 2 years of medical school during my PhD to really try to get that connection to medicine, medical practice. And I think that really helps with collaborations with physicians and even our clinical trial work today. And during that time, I worked at MIT with Bob Langer in the area of tissue engineering. So we focused on building biomaterial scaffolds to serve as a framework for cells, and we focused on cartilage tissue because it's a great target because when this tissue is damaged, it cannot repair normally. And, when you think of aging, it's a tissue that generally degrades with age, and the rate of osteoarthritis in the aging population is huge. And we're seeing some interesting data now connecting arthritis with other changes in the body. Anyway, after that, I went to try to learn some biology, developmental biology. So if we're trying to rebuild tissues, whether it be due to trauma or aging, it'd be nice to know how they formed, and can we use those elements of how the tissues formed to design or repair strategies. And then finally, when I started at Hopkins, stem cells were. Did you want me to?
No, never mind. No.
Okay. So when I started at Hopkins, stem cells were recently discovered, both adult and embryonic. So we focused on, number one, how we can build and engineer biomaterial systems to guide stem cell differentiation and understand some more fundamentals of materials cell interactions. And that's where we bring in some of those developmental biology aspects in addition to the material science. At the same time, we wanted to be designing therapies that could be used in patients today. And so we started some translation efforts, which connects then to the startup companies, both in cartilage repair and soft tissue reconstruction.
Yeah,
And
so,
yeah, go ahead.
are you done yet, or?
Well, I'm doing very different things today that really connects to our translation experience. So our clinical trials and really looking at the data and trying to understand what was going on led to a major shift in my research to then focus on the immune system and its role in tissue repair, in particular the adaptive immune system, T cells, and how can T cells and the immune system be leveraged to promote repair? And then instead of using biomaterials as scaffolds, we're using biomaterials to model different immune environments, including an aging environment.
So, as you probably know, this podcast, we have several people that came from the Bob Langer's lab and who've been on here. So I asked them this. So what do you learn from your experience working with Bob Langer?
So I think two things really pop into my head. Number one, translation, right? So I think the experience there and the importance of translation and bringing therapies and the complexities of that, right? Seeing if we are designing completely new systems, manufacturing and regulatory is a real challenge in addition to the clinical. So I think the experience not only gave the seed of the importance of translation, but also a lot of experience in that process. And then number two, really the source of creativity and innovation at the intersection of fields. And it's not always easy to jump into new fields. And I think the experience really taught me the importance of that, and to jump in and go ahead and do that.
Yeah, so I see you're an ophthalmologist in your bio. So I think
No,
most of
no,
the
no.
audience.
I'm in Wilmer space, but I'm not an ophthalmologist.
Oh,
Yeah.
okay, so not okay. I see. So, yeah, my next question is: I see you're just on the scientific advisory board of Boston Lombs, and
That
I
was a
know
long
that.
time ago. Again, not
Yeah,
anymore.
and
So
I
that's been
know.
about 10 years.
So I just want to ask, just generally, I think with healthcare costs on the rise, and eyeglasses and contact lenses are pretty expensive. So, do you, can you think of some ways that can help decrease the cost of these contact lens and glasses?
I don't know how much of that's an innovation and science question versus a business question,
Oh, okay.
right? I would say a lot of things are priced at what the market can bear.
I see. Okay.
So I don't know if there's that. There are clearly low-cost alternatives that are even companies here are building for developing countries. So I think it's a question of what the market will bear. And if you look at the daily disposables, the per contact lens cost there is pretty small.
hmm Yeah. So I think you mentioned you were interested in tissue engineering and aging. So what do you think are some ways to repair tissues that start degrading as someone gets older?
Yeah, so the first thing we've done in that space is to really, again, focus on the adaptive immune system and T cells and its communication with the tissue-specific cells. So it's been recognized for quite a long time that older people take longer to repair tissues and wounds. And people have been studying the changes with stem cells with aging. But I think the immune system is particularly interesting as a target with aging because there is inflammaging or inflammation that increases with aging that is easily observed in pretty much every model, and that's something that can be therapeutically targeted, and that impacts sort of the communication network that we see that connects with repair and also scar formation. So what we see with aging is more a scar-like inflammatory pathway and more communication, for example, between senescent cells and T cells.
Mm-hmm. So, I have a question. I mean, this is regarding aging. So, I see on the internet a lot of people, and then some prominent scientists are promoting anti-aging and fountain of youth research. So, my question for you is, I mean, you're kind of involved in the not in the field, but you're involved in aging and tissue entrance. Like, so what do you think of this research and what they're promoting?
Um, well, I would say the typical, or I would say we need to be careful and look carefully at the data. And the field is really in its infancy. And it's something that obviously touches all of us here, right? We're all aging
Mm-hmm.
as we speak. And it can be very easy to sort of fall for simple solutions, right? And in a pill form, right? Instead of the simple solution, at least of trying to age healthy with exercise and diet and things like that. I think there are going to be exciting developments in the area of health span, let's say, so how we stay healthier longer. And again, I think targeting aspects of the immune system will be important for that. But I would say I would approach it with skepticism initially and really try to look at the data. And you can see, at least on social media, a lot of arguments between different aging researchers about this. And I think we need to be careful for hitting vulnerable parts of, people, right? And the fear of aging is something that we are all vulnerable to at some points, and just be careful with people that are using that.
Guys, make sure to check out Dubby Energy, an energy drink company with no artificial colors, sugars, or calories. And guess what? It can fool up your whole day. Trust me. Use my promo code Diamondgoat for 10% off for every purchase you make. Yeah, so you're also working to develop an artificial cornea. So can you talk more about this and what materials do you think you can make it out of?
Yeah, so again, we've shifted a little bit away from that research, and we've licensed that technology out to companies to move that forward. But we've been making it from really primarily the same components that our native cornea is made from. The challenge with it, and what makes the cornea quite interesting, is that collagen in your skin is in your skin, and collagen is in your cornea. So why is your skin opaque and your cornea transparent? And it's really the organization of that collagen. So we used material science strategies and self-assembly strategies to help make a cornea substitute that has the same strength of your native cornea and is also transparent.
Yeah, and I know you mentioned that you already you're not working on this, and you've I
Licensed
guess
it. Licensed it out. Yeah.
gave the product to the company. So is this product now on the market, or is it still in development?
It's still in development. I believe they've done the company has previously done some clinical trials in some early clinical trials, and figuring out now how they're going to develop further and extend the clinical trials.
Yeah, and I want to ask, you were working more in the eye field, kind of. Why do you pivot from working more in the ophthalmology field to the I guess more of the engineering and a tissue side?
Well, we've always been in more musculoskeletal system, and we just had the one project in the cornea and also on the lubrication layer of the cornea. And really connects to collaborations, and ophthalmologists came to us and said, hey, there's a real clinical need here, or can we work together to develop some new solutions, which is always a great place to start a collaboration, right? Of having the two people working together. And interestingly, there are actually a fair number of general similarities between the cornea and cartilage in your knee. They're both avascular tissues without a blood supply. They both have an interesting organization of collagen and proteoglycans. And we're even looking at this one proteoglycan that seems to be present in scar that we thought was sort of unique to the eye. So I think we learned a lot as we look to repair these various tissues.
Yo, what is up, everyone? It's Diamondgoat. Make sure you guys check out Musely, an all-in-one audio super app for iOS and Android. It picks up the most trending articles on the web on topics you choose at any given moment and reads them to you in a natural human voice. For the first time ever, the entire web becomes listenable, all in one place. Browse articles from the topics you choose to start playing. Stop scrolling, start listening. You can follow any topic as specific as you like, from sports, tech, business, science, Dogecoin, or even Elon Musk. It will find you the latest articles and read them to you aloud. And they will have podcasts as well. Explore trending podcasts from over 80 countries. My podcast is there too. I started using it as my default podcast app. They even have a digital radio. Download and use Newsly for free now from www.newsly.me or from the link in the description, and use promo code DEARLY link in the description and receive 1 month free premium subscription. Yeah, and I want to ask, you were working more in the eye field, kind of. Why do you pivot from working more in the ophthalmology field to the I guess more of the engineering and a tissue side?
Well, we've always been in more musculoskeletal system, and we just had the one project in the cornea and also on the lubrication layer of the cornea. And really connects to collaborations, and ophthalmologists came to us and said, hey, there's a real clinical need here, or can we work together to develop some new solutions, which is always a great place to start a collaboration, right? Of having the two people working together. And interestingly, there are actually a fair number of general similarities between the cornea and cartilage in your knee. They're both avascular tissues without a blood supply. They both have an interesting organization of collagen and proteoglycans. And we're even looking at this one proteoglycan that seems to be present in scar that we thought was sort of unique to the eye. So I think we learned a lot as we look to repair these various tissues.
Yeah. So, I mean, I know you're also working on wound healing and cancer. So can you talk more about that work that you're
Yeah, we're very excited about that. We work in the area in the area of cancer immunotherapies, and that's really what connected us with T cells. And we're applying a lot of the cancer immunology techniques to wound healing and biomaterials to characterize these environments. And so we've looked at how some biomaterials might modulate the tumor microenvironment to either stimulate tumor growth or reduce the tumor growth. But the real exciting area is understanding how different tissues in the body may communicate with each other to impact therapeutic response. For example, if we put a muscle wound in an animal and look at distal tumor growth and response to therapy, the muscle wound actually increases tumor growth and reduces responsiveness to therapy. If we put an injury in the joint and develop arthritis, it actually decreases tumor growth and increases responsiveness to immunotherapy. So even though the tumor and these wounds are in different places, they impact the tumor environment and potential therapy. So cancer immunology has made great strides in treating patients. But there are some people who don't respond or are resistant to the cancer immunotherapy. So through studying how wounds impact the tumor environment, we're uncovering aspects of why some tumors are resistant and how we can potentially move them to being responsive to therapy.
Yeah. So is it just one cancer you're focusing on right now, or is it all types of cancer? Like, is there a specific cancer type you're
Well,
trying
so
to
in our
look at?
models, we're looking at different cancer different cancer types. And actually, as we're comparing it to clinical data, we're looking at multiple different tumor types. And the interesting thing about cancer immunotherapy is that it's a little bit more agnostic of tumor type, right? So if you think of mobilizing your T cells to fight cancer, increased mutational burden in the tumor does make an impact in the response, but and different tumor types will have some differences in response. But we're looking at this as a general theme of how these different tissue perturbations or wounds impact a distal tumor, which is really applicable to multiple different tumor types, particularly as if you get surgical resection or getting your tumor removed with surgery, that's going to create tissue damage. So understanding how that impacts the tumor and physiology is important.
Okay, so we're gonna move on to your company. So I know you co-founded Cartilax back then. Now it was acquired by Biomet. So can you explain what Cartilax is and what products they made?
Yeah, so Cartilax was focused on building an adhesive and hydrogel environment that worked in conjunction with a standard surgical procedure in the joint called microfracture, where you would essentially drill a little bit into the bone underneath the cartilage to enable some bleeding in that space. And we put the biomaterial in there to help enrich that. Enrich that and create an environment that supports new cartilage development. So it was an adhesive hydrogel combination to stimulate endogenous repair or your own body's capacity to repair the cartilage.
Guys, if you guys love reading books, make sure to check out Audible and use my link audibletrial.com/diamond for a free 30-day trial. Regarding Cartilax, I assume this is your first startup. So how was your experience founding your first startup through?
Well, I would say each company has its own challenges, right? So there are always new pitfalls and unexpected challenges that come in any company. And so I think what I learned a lot during the Carlos experiences was related to manufacturing, and particularly as you get into more complex biopolymers, the challenges in manufacturing those was something that was new. And then getting involved in clinical trial design, I think, was quite fun and interesting.
Mm-hmm. Yeah, so my next question is, I know Biomed acquired Cartilex, so I actually looked at an article and they said Cartilex had raised $6.5 million in Series A funding, but it was acquired by a larger company. So it's kind of weird, and I've interviewed several scientists who've had similar weird, I guess, environments where they get acquired. So why do you think Biomed acquired a startup that was a Series A? Like, do you think because it was the employees or because it would, Cartilex had a great product or patent that they wanted?
I think it depends a lot on the industry. In the orthopedics industry, I think one of the challenges in the orthopedics industry is that the standard of care are these metal and plastic implants for the knee and the hip. And a lot of the companies that manufacture those, they definitely do want something that is next generation, that is not artificial, where you can regrow. But it's very different as far as manufacturing and sales and even how you run the clinical. So the expertise of those companies doesn't always overlap with the regenerative therapies. And actually Biomet was acquired then by Zimmer. So it was like multiple acquisitions that layered into that. So I think it was a space, a research space that was recognized as being cutting edge and where the field was moving. Just like the bone morphogenetic proteins, growth factors, and platelet-rich plasma. So, I think there was a recognition that biological therapies were the future and what people wanted. Having a small, minimally invasive surgery instead of a larger surgery, putting in a permanent implant is something that people wanted to delay.
Mm-hmm. Yeah, and and just regarding, I guess, biomaterials, so is the clinical trial process easier than just uh doing a trial with some drugs or a new type of therapy? Like, is it easier, like, kind of thing?
You mean with our with the regenerative medicine technologies?
Yeah, is it easier? Is it less money than doing it with a new drug or something?
Well, I mean, device trials tend to be a little bit easier than drug trials, just as far as the numbers of patients and the cost. But they're different challenges, I would say. So it has different challenges, I would say. We don't have to do pharmacokinetics with the device, but then there are challenges with how are you going to put the device in there. And there's always going to be the challenge, no matter what, of what is the patient population that you're recruiting, the criteria, and what are going to be your primary and secondary outcomes. So particularly in the case of cartilage repair and even arthritis, understanding how to classify patients is critical.
What is up, guys? It's Diamondgoat back again. Make sure to check out Libysn, a podcasting distribution platform. If you want to start your own platform, use my promo code DG to sign up for 2 months free of Libysn. Sign up on www.libysn.com. Mm-hmm. So you also founded Igeria soft tissue,
Yeah.
and so it seems like the first part of the company seems interesting. So why you named it that way? Is it because it's named after someone, or
Cartilix or Igeria?
Igeria.
Igeria is a mythological figure. So it was Roman, the Roman goddess of rejuvenation. So that applies nicely to regenerative medicine.
Yeah, so can you talk about what products did Igeria make?
Yeah, so we're in phase 2 clinical studies right now. We essentially, again, are trying to use materials to promote the body to repair. itself, and this is for soft tissue reconstruction. And we recognized with our clinical collaborators, again, that importance of the engineer and clinician working together, that the clinicians were doing a lot of fat grafting, which is essentially moving adipose tissue around, and that's a nice way to contour tissues, contour the body. And we also recognized there were not many options for people who had soft tissue defects in the face, and then also things like lumpectomy for smaller defects that are still on the larger side, but smaller than a full implant. And so essentially it's taking the adipose tissue, removing the lipids, which can be inflammatory, and the cells, and creating a suspension slurry that supports cell migration and new tissue growth, and feels from the clinical perspective like native fat tissue. So essentially moving adipose around.
So I know I jury partnered with the military for the first phase trial. So I wonder what was the reason behind it, because I know usually I've asked other scientists, they said, oh, we're either doing with a hospital or something else. So why the US military?
Well, we're running the clinical trial here at Hopkins. It's being supported by the military, and this work started in during the Middle East conflicts, where you had a fair amount of you had people coming back with some soft tissue reconstruction or soft tissue defects that needed reconstruction. And as we talked about for orthopedics, and even in the face, you can replace bone, right, with a metal or plastic implant, but the soft tissue, which really creates the shape in your face, in conjunction with the bone, having a method to replace that and work on reducing scar formation and sort of restoring the tissue, the original shape was really the goal.
If you guys are a fan of my podcast clips, I think you guys should go check out Opus Clips, a website where you can upload your whole podcast episode and split it into 30 short clips to increase your engagement. Use my link for 30% off for the first month of a pro plan. Just use my link opus.pro/diamondgoat30. Okay. So is there any advice that you received during your career that shaped your professional development or success?
Oh, there was, I think, so much advice at different stages, and having mentors that you can brainstorm with, get advice from, I think that's a key aspect. So not just when you're junior or developing, but all throughout, having people that you can both scientifically and sort of career life-wise be able to talk with and get advice is I would say central.
Is there any particular advice you want to give to students? Specifically, you want to pursue STEM or business?
You brought up aging field and what's being marketed now with that. And my advice is to try to think long term, even though I know there's a lot of pressure in the short term, but try to think long term. And sometimes paths that might take a little bit longer and take you on diverse pathways allows you to be different and have unique combination of expertise that will allow you to be more creative. And also really try to think about what you're passionate about and making a positive contribution.
Mm-hmm. So do you have anything else to add to this interview?
I don't think so. Thank you for doing this. And
all right.
I hope it's useful.
Yeah, and thank you for being part of this episode, giving me the chance to talk to you so people can get to know more about your insights into tissue engineering and also business.